Okay, we're looking at Calc 1, Section 5.4. Going to work through some problems here, once again, dealing with definite integrals and symmetry, and then our mean value. Now, considering problem number 8. Problem number 8 talks about the integral from negative 200 to 200 of 2x to the 5th dx. Now, one of the things that we always want to consider is we want to consider what is this function inside here. Okay, so if I were to come over here and go f of x equals 2x to the 5th. If I put in a negative x in here, that means I'm going to put a negative x in under this 5th, in which then we talk about this f of negative x right here. The negative to the 5th power would be a negative 2 and x to the 5th. So we see that f of x is the same, or is equal to the negative, or not equal to, that f of x is 2x to the 5th. If we put in a negative x, we get negative of f of x. So if we were to think about this, f of negative x equals negative f of x, which means that this function is odd. So that means because we're from negative 200 to 200, now this is the only reason why I checked even and odd, was because this was an negative to a positive right here. There are a couple other times we do it, but once again that comes with periodic functions, and we'll look at a problem there a little bit later. Considering this whole issue right here, because this is an odd function and we're going from negative a to a, I know it's 0. Okay, but let's say I didn't know that. Let's just play into the fact that I don't want to go through this process, and once again this could be done mentally for this easy of a problem, to where we could have went straight to that 0 because of an odd function. Well, let's play into the fact that we actually want to evaluate this. So if we actually evaluate the integral part of this, we're going to add 1 to our exponent and then divide by that new exponent. So we have 2 over 6, or 1/3 x to the 6, and then we're going to evaluate from negative 200 to 200. Okay, so that means we're going to take 1/3 times 200 to the 6 minus 1/3 times a negative 200 to the 6. Okay, if we consider everything that's going on here and all the parts of what's happening, we'll consider the fact that this negative is to a 6th power. So we really have 1/3 200 to the 6 minus 1/3 200 to the 6. Because once again that negative comes in right here. Well, we're really subtracting the same thing, so I don't have to take 200 to the 6th power, because depending upon the calculator I have, might raise some issues into what this value actually is right here. So this equals, once again, 0, because this product minus the exact same thing, something minus itself, is 0. So basically it's showing that we have the 0 overall with everything. It's just not working precisely into it. Number 10. Number 10 talks about the integral from negative pi fourths to pi fourths of cosine x dx. If we were to think about this function, f of x equals cosine x, f of negative x equals cosine of negative x. Cosine of a negative angle is cosine of that angle. So once again, the negative angle is the positive angle. The negative angle have the same cosine values. That's one of our trigonometric theorems. So we have this right here. So basically we get f of x, or I'm sorry, f of negative x equals f of x. So we have an even function. So what we can do now is we can evaluate this a little bit differently. We could state that this integral is 2 times from 0 to pi fourths of cosine x dx. So if we take 2 times the integral from 0 to pi fourths of cosine x dx, now once again this is going to be 2 times. Let's evaluate this out. So if we evaluate this out, the integral of cosine x would be sine x, and then we're going to evaluate this from 0 to pi fourths. So we have 2 times sine of pi fourths minus sine of 0. Sine of 0 is 0. Sine of pi fourths is pi root 2 over 2. So we have root 2 over 2 minus 0. So this tells us that we have the square root of 2. If we were to go back and evaluate this all the way from negative pi fourths to pi fourths, we would see that we'd have some issues in here. I wouldn't say some issues, but we'd have just some little more work to look at. Okay, so if I just come right here and I have this, but let's say we didn't do this 2 times the integral here, and we left it as this original. So that means we would have had the integral of cosine x would have been the sine x, but now we're going to evaluate from negative pi fourths to pi fourths. If we consider this now, we're going to go sine of pi fourths minus sine of negative pi fourths. Sine of a negative angle, so once again, sine of pi fourths. Sine of a negative angle is negative the sine, so I have minus a negative sign, so it's really plus sine of pi fourths. So that is root 2 over 2 plus root 2 over 2, which is 2 root 2's over 2, which is root 2. Once again, either way we evaluate this, we get that square root of 2. So we're seeing that symmetry shortens up our basic mathematical operations, especially if we have this odd symmetry. Bam, we're to an answer versus having to go through that even parts. Now, we don't always have to reference our even parts based off of what's happening. We could always reference them off of other issues going on within here. For instance, if I were to come back here, and once again this gives me net area, but let's say I want a total area. Okay, total area, notice that these would cancel each other off. So if we're getting an area of 0, that means we had double half that interval. So we could treat this then as what an even function would be and work a little bit better with that to find out precisely what's going on. Let's go to number 22 now. Okay, 22 talks about the average value. Okay, so if we talk about the average value in here, here they tell us f of x equals x squared plus 1, and we want the interval from negative 2 to 2. So basically over this interval we're trying to figure out what is the average value. So out of all our functional values, what do we have going on? So if you remember, we're going to find f bar. Okay, so f bar equals 1 over, we're going to take b minus a, so our upper bound minus our lower bound, times the integral, once again from our lower bound to upper bound, of that function dx. So, starting to simplify, we have 1 over 2 plus 2, so that's 1/4. Here we have the integral from negative 2 to 2 of x squared plus 1 dx. So if we take that x squared, this would be 1/3 x cubed, taking the integral of this part, taking the integral of here, this would be plus x then. And then we're going to be evaluating from negative 2 to 2 on this. Now it's just basically solving. Okay, so we're going to take this 1/3 times 2 cubed plus 2, and then we're going to subtract off having this 1/3 times negative 2 cubed plus a negative 2. Okay, so considering this, we have 1/4 times, now we have, let's see here, this is 2 times cubed, so that's 8/3 plus 2, and then this would be a negative 8/3, so I'm just going to go like this, minus, we have a negative 8/3 minus 2. I hope some of you are catching this at home of what precisely is going on here and realized how I could have shortened this work up tremendously. But I'm doing this on a purpose so you can see the value in symmetry. 8/3 plus 2 plus 8/3 plus 2. Wait, I just doubled this, didn't I? You think back, x squared plus 1 is an even function. It reflects on that y-axis. So rather than stating this from -2 to 2 right here, I still need this part here. So don't get me wrong and say that this is 2 times. We need to have this part right here because this is the overall function. But when we come down here, I could have did 2 times 0 to 1, evaluated from 0 to 0 to 2 on here because it's an even function. But I didn't, so I have all this here. So if I add all this together and then multiply by 1/4, we see that we get 7/3. Okay, so overall on this function, on this curve, we're seeing that the average value from -2 to 2 is going to be 7/3. Okay, so we always want to figure out, well, what's average on this? Well, this is how we go about that process in here. Now considering 34. Okay, question 34, they give us a wave problem. So we actually have a little story problem in here. Here we talk about the average height of a wave. So it says the surface of a wave is described by y equals 5 times 1 plus cosine x. And then they tell us this is from negative pi less than or equal to x less than or equal to pi, where y equals 0 corresponds to a trough of the wave. Find the average height of a wave above the trough on this wavelength. So then they give us this whole shape on here, and we basically have the graph of what's going on with this. So if we have, that's 2, 4, 6, 8, 10. If we go negative pi halves, negative pi, pi halves, pi, we see that we have, let's see where my 5 at right here, here. We have this overall curve that we're talking about on here. Well, looking at this curve, we most definitely can see that this is y-axis symmetry. Okay, so we have an even function. Okay, now once again we could plug in a negative x into here. Cosine of negative x is cosine x, so, and that's the only x that we have in here. So we see that we have an even function overall. Now, considering this, we want to figure out the average wavelength. Okay, so we want to figure out that average height of the wave. So we're going to take 1 over pi minus a negative pi, the integral from negative pi to pi of our 5 times 1 plus cosine x dx. Because this is an even function, the previous one I didn't work it out as an even function on there. It would have very easily been done, but I didn't. So I'm going to show you how we're going to work this one as an even function. So once again, our average wavelength, I'm going to simplify this down. This is 1 over 2 pi. And then now, because this is even in here, this is 2 times the integral from 0 to pi of 5 times 1 plus cosine x dx. Now that we have this even function in here, we can work with it a little differently. Now, I'm going to do a couple things as I do this one. One of the things is, and I forgot to do here, was I could also bring out this 5. Okay, so I can bring that 5 out as a product in here. So if I bring this 5 out and I take 1 over 2 pi times 2 times 5, I have 5 over pi. Okay, so now that I have 5 over pi, and I can write this integral one more time for you so you can see that we'll really only need to evaluate this 1 plus cosine x in that integral part because of that constant multiplier. So, evaluating this, integral of 1 is x, integral of cosine x is sine x, and then we're evaluating from 0 to pi on here. So that means we have 5 over pi. Evaluating this, we're going to substitute pi in here, so we get pi plus sine of pi, minus, then we're going to have 0 plus sine of 0. If we consider this first one right here, we have 5 over pi. This is pi plus 0, because once again sine of 0 is 0, minus 0 plus, let's see, sine of 0 is 0, so this is 0 overall, so minus a 0. So basically we have 5 over pi times pi, which gives us 5. So we're seeing that the average height of this wave is 5. Okay. Now, why is this important? This is important because for a majority of the time, because that's what that average starts relating towards, we should be seeing that we should be around that height of 5 and not be on the lower extremes or those upper extremes of that overall wave height. And that's where then people can worry about when ships are coming in, once again because of the wave motion of this, or even people swimming. Looking at one last problem here. We're going to use our mean value theorem for integrals. Okay, so let's look at number 36. And number 36 isn't going to be an even or odd function on here, so we don't have to worry about that, once again, because this is an exponential function. F of x equals e to the x, and then we're going to go interval from 0 to 2. So basically what it's asking us, it's telling us to find the value of c for which the mean value or the average value of the given integral is happening right here, so of this function. So we're basically trying to find f of c equals the average value of the function. Well, the f of c part is very easy. I'm going to go e to the c. I'm going to plug that c in here, and I'm going to write the function instead of terms of x in terms of c. Now, we have to remember back we have to solve for the c as we continue on. On the other side, I need to find my average value of this function. So the average value of the function overall is going to be 1 over the upper bound minus the lower bound times the integral from 0, lower bound, upper bound, of my overall function. Okay, now please remember I'm using x in here, and I said I need to solve for c, but if you remember, because of the definite integral, when we substitute in, that x is going to be gone. So we have e to the c equals 1/2. The integral of e to the x is e to the x. So we have e to the x evaluated from 0 to 2. So now this is e to the c equals 1/2 times, putting this in, we have e squared minus e to the 0. So this is e to the c equals 1/2 e squared minus 1. Now, we need to figure out what c is. Okay? So there are a couple different things we can start working with on here, and it all depends upon how in depth we want to go with this overall problem. But considering what this is stating e squared minus 1 all over 2. Okay? Now, we can change this to be our logarithm, or natural logarithmic form. So c equals the natural log of e squared minus 1 over 2. And there we go. We have a nice answer here. Now, we could work on breaking this apart. You know, we could say this is the natural log of e squared minus 1 minus the natural log of 2. We can leave it like this. One of the main things is we should probably put an approximation on here overall. So we see 1.16144 is what this value is getting at overall. But it's all going to depend upon where we need to go and what we need to do with after this. So it's always good to get everything to exact answers first and then go to that decimal, because we don't want to start rounding way up here, because we're going to start running into issues as we compound those operations. It's going to worry about significant digits. A way to get around significant digits is to work with everything as exact values and never round until the very answer.